Rule number 5 simply says that A, watch it now, to the power of m divided by n, see? Thing nice now. Is equal to A to the power of 1 over n in brackets all to the power of n. Now, listen man. There are plenty things we could do with that rule alone. And we're going to start by doing a few examples. To the power of m, sorry. Because I know what you're asking yourself. You want to know what this 1 over n is, right? Yeah, you want to know what that is? We will discuss that just now. I wonder if I should do that as a separate video. No. I might change my mind, but anyway. So what is a to the power of 1 over n? Let me do some nice examples now. Let me do some examples. Let me explain. Let me just write it down. So if I say that 16 to the power of 7 over 4, that is equal to 16 to the power of 1 over 4, in brackets, all to the power of 7. 16 to the power of 1 over 4 is 2, to the power of 7, which is 120. That's one example. Let me choose another example. 7, 3. Let us say 7 cubed is 343, right? Let us say, if I say 343 to the power of 2/3, see how nice it is? It's looking harder. That is the same thing as 343 to the power of 1/3 squared. 343 to the power of 1/3 is 7, which is 7 squared, which is equal to 49. Now I use two very specific examples. This is not one of those occasions where I just pick any number in space and put it on the whiteboard. I have to pick very specific numbers because I want to make the thing real first, and then once you understand it using what I would refer to as perfect powers and exact roots. Perfect powers, exact roots. Yeah, that's sounding good. Perfect powers and exact roots. Then you will catch it a little better. Let me use one more example because I want to start with a power that you're already familiar with. Let us say that 64. 8. No, not too big. 36. 2, 7, 3, 4. 4 squared is 16, 4 cubed is 64. 4 cubed is 64. 4 squared is 16, but we use 16 here already. 6 squared is 36. 36. Alright, let me try 36 and see. 2, 7, 6. Let me go with 5. 5 is a nice number. So let me say 25 to the power of 3 over 2, right? That is the same thing as 25 to the power of a half, all in brackets, to the power of 3. 25 to the power of a half is 5, which will be 5 cubed, and 5 cubed is 125. Right, so now we start to talk, man. Where the wet cloth I was using just now? Let's see how it is when you're making a video in a humanistic form, right? Whiteboard and marker and cloth and thing, right? We're trying as much as possible to retain the human touch, even in the presence of multiple technologies, right? So this, in case you didn't realize, is a simple variation of the last law we did, where we said that a to the mn, sorry, where we said about that a to the power of m by n is equal to a to the power of mn. Basically, all we're doing is going back in the reverse now, and we are saying that a to the power of m is equal to, sorry, a to the power of mn, we started with a to the power of mn, and we're saying that a to the power of mn is equal to a to the m in brackets all to the power of n, which is exactly what we have here. So instead of a to the mn, what we're going to start off with here, instead of m multiplied by n, we have this thing that takes so long to dry. We have a to the power of m over n. We're starting with that because these fractional powers are a special category all on their own. So we'll have a little semi-discussion about that in there somewhere. And we're applying the same principle here, but instead of the m inside, we're taking the 1 over n on the inside, because it doesn't matter which one they have on the inside. Let me illustrate that. So we have basically, yeah, you're taking m over n. Remember that m over n is the same as m, let me say m over 1 multiplied by 1 over n. So you're expressing m over n as a product, m by 1 over n, in the same way that you have m by n. The only difference is that instead of n, you have the reciprocal of n, which is 1 over n. So a by m over n. Now you could do this in one of two ways. You could either say a to the m to the power of 1 over n on the outside. You could do that, or you could say a to the 1 over n on the inside multiplied by m on the outside. The order in which you multiply doesn't make a difference. We know that multiplication is commutative, which is to say that the order in which the multiplication is effected doesn't make a difference. In the same way that we could then write here, watch what I'm going to do here now. Right? If we start off with a by m, all in brackets to the power of n, and we agree that this is equal to a to the power of mn, then we can say also that that is equal to a to the power of all to the power of m. Remembering, of course, that mn is the same thing as nm. Alright? So the order doesn't matter when you're multiplying. 2 by 3 is the same thing as 3 by 2. So basically, what we do in here, and I want you to slow down. If you're distracted, this is the point where you need to eliminate or reduce as far as possible the distractions that you have. Excuse. Pressure. Excuse. Even if it means pausing the video at this point to come back later. Well, or you can let it run and come back later and watch it. That is the advantage when you have these recording technologies. You could just watch it over and over as many times as you wish. So here now is where you need to concentrate, because you're going to go a little deeper here now. So we invoke the commutative property of the multiplication to involve what we refer to as the root. Right? So I will spend a little time talking about the root. I might even go as far as to extract this part from this video and have that as a separate video where we're talking about the root, because the root is an essential part of anything that we're talking about when we're talking about powers. So you have what I referred to as perfect powers a while ago, and then you have exact roots. What does that mean? Simple examples. We spoke in an earlier video about squares and square roots, where the power is 2. Yes? So 3 squared is 9, and 4 squared is 16, and 5 squared is 25, and 6 squared is 36, etc., etc. So those are what we refer to as perfect squares. You're squaring it, so it's a perfect square. You could apply the same idea to cubes as well. So you might have perfect cubes, right? 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. We don't have much space on the board. Let me take a little trick here. You see, one of the things I realize is that even when you're talking about stuff, it always pays to illustrate what you're talking about. Of course, it's a little more work for the teacher, but where you go to, that comes with the territory. So we go in with the perfect squares, right? Now we can talk about the squares because most people have some level of familiarity with the squares. Perfect cube, right? 2 cubed is 8, 4 cubed, no, 3 cubed, because I want to give you the opportunity to see it. 3 cubed is 27. 4 cubed is equal to 64. Well, you have 5 cubed is equal to 125 here. So the perfect cubes, you have the integers multiplied by each other 3 times to give you these. These are what I would refer to as perfect cubes. 8, 27, and 64. So 64 is a nice number in the sense that 64 is a perfect square. 8 squared is equal to 64. 64 is also a perfect cube. 4 cubed is equal to 64. 64 is also a perfect 6. Because 2 to the power of 6 is 64. I don't know the exact word for 6, but you understand what I'm saying. Right? 2 to the power of 6 is 64. So the number 64 is a kind of sweet spot anytime we want to illustrate the concept of powers, right? Exponents, indices, and later on there's a thing that we call logarithms, which is the flip side of powers. The number 64 is also an excellent way to illustrate that. That is one of my strategies. You know, you talk, and then you use an actual number to illustrate the concept. 64 is one of those numbers. So if you are doing a level of maths where you have to deal with logarithms, then look for my video where I used the number 64 to illustrate the connection between indices and logs, and to illustrate the whole concept of the different bases within the logs. So enough about that. You can have perfect 4s and perfect 5s and all of that, but the point about it, once you have a perfect power, it means that we're dealing with integers. If you have an exact root It means we also dealing with integers. So the third root or the cube root of 8 is 2. Because if 2 to the power of 3 is 8, then, and I want you to look at this carefully now, it means that 8 to the power of 1/3 is equal to 2. Right? And if 3 to the power of cube is 27, it means that 27 to the 1/3 is equal to 3. And if 4 to the power of 3, did I say 3 to the power of cube? Can't remember. But 3 to the power of 3 is, when you're talking over an extended period of time in this video, sometimes you listen to what you say, but sometimes stuff does pass. So all you'll forgive me, alright? If I make a mistake, that is. So 3 to the power of 3 is 27. 27 to the power of 1/3 is 3. 4 to the power of 3 is 64. It means then that 64 to the power of 1 over 3 is equal to 4. This in this column here is what we refer to as the cube root, the third root. Let me do the same thing with powers of 4. Alright, so you have the cube, perfect cube, and then you have the exact root, the cube root. All integers. Let me continue. Alright? These topics just take a lot more time to explain, Yeah. So we go in. Let me go with 4. 2 to the power of 4 is 16. 3 to the power of 4 is 81. 5 to the power of 4 is 625. So we're going again. With all of those, what does that mean? It means that the fourth root of 16 to the power of 1 over 4 is it? Oh, come. That's looking like a mixed number, man. Jeez. Better than that. 16 to the power of 1 over 4. You see how careful you have to be when you're writing these things? If I write this 1 over 4 too big, it will look like 16 1/4, which is not what I'm trying to say. So I just want to take this opportunity to encourage you guys, be very, very careful of how you write this stuff. Especially with this topic of powers and indices, because there is a very specific need to write the powers a little smaller and up in the right hand corner. That is the convention. Whether the power is an integer or a fraction or a rational number or an irrational number or a decimal or whatever it is, you must put your powers up in the corner and a little smaller than the base. If you don't do that, it could easily be misconstrued for multiplication, or as almost happened here, it could look like a mixed number if you're talking about a fractional index. So if 2 to the power of 4 is 16, then 16 to the power of 1 over 4 is 2. See? One side of the coin, the other side of the coin. If 3 to the power of 4 is 81, then 81 to the power of 1 over 4 is equal to 3. That's 81 to the power of 1 over 4, not 81 1/4. And if 5 to the 4 is 625, then 625 to the power of 1 over 4 is equal to 5. So you see that pattern here. So having used powers of 3 and powers of 4, I am now going to revert to the power that we are all most familiar with. Powers of 2. Just to drive the point home. Because if you understand the pattern here, maybe you ain't understand it so much. You're not too sure. Then I am almost certain that the pieces will fit when we start to talk about squares and square roots. Which law that is? Right, that's the next law. So I will have to bring in that law here. Here, you see, I tell you, the thing gonna get nice. It's gonna get real nice. Alright? So watch it now. Watch very, very carefully what we're going to write now. Thing getting serious. So if I have, whichever one of my orange ones to use, boy. If I have, there we go. Nah, let me use numbers that you're familiar with. I get tempted there for a minute, eh? Let me say 2 squared is equal to 4. Let me say 6 squared is equal to 36. Let me say 9 squared is equal to 81. So you see 81 is a perfect square. 81 is also a perfect fourth. Perfect 4, perfect whatever. Right? Because 3 to the power of 4 is 81. Right? So 81 is a perfect square, 36 is a perfect square, 2 is a perfect square among all the others that I would have been encouraging you all to learn in a previous video. So if 2 squared is equal to 4, it means then that 4 to the power of a half is equal to 2. And if 6 squared is 36, it means that 36 to the power of a half is equal to 6. And if 9 squared is 81, it means that 81 to the power of a half is equal to 9. So we know that the square root of 4 is 2. We know that the square root of 36 is 6. We know that the square root of 81 is 9. But notice I write it in index form. Instead of saying the square root of 4, I have 4 to the power of a half. Instead of saying the square root of 36, I said 36 to the power of a half. Instead of saying the square root of 81, I said 81 to the power of a half. What we're really trying to do here? What we're trying to do, I had to come back here in blue now, so I'm taking a little piece of the board in the corner here for the time being. What we're trying to say is that, watch carefully now, right? And this is rule number 6. What we're trying to say is that a to the power of 1 over n is equal to the nth root of a. A under the square root sign with an n on the outside. In the very special and particular case where n is equal to 2, where we're dealing with square roots, we're saying then that a to the power of a half is simply equal to the square root of a. This is rule number 6. This is rule number 7 on my sheet here. Again, I have it a little different to how most textbooks would have it. And of course, the next step would be to have a little print out of this so that you can have it in your hand and read it. And after, of course, I mean, if you're watching the videos here, watch the videos, but it is always nice to have a nice little printout in black and white. So it means then, so now that I have it here, I'm going to rub off and go through the illustrations. It means that, watch it now. Let me use some examples now. It means that the square root of 36 is the same thing as 36 to the power of a half, which is the same thing as 6. You see this? Everybody know that the square root of 36 is equal to 6. We know that. What we're not so familiar with is that that could also be written as 36 to the power of a half. That little piece of knowledge there would pull you out of many a ditch in different case situations in maths, algebra and whatnot. And that is why I'm spending so much time talking about it. All you have to do is find a way and figure out a way to pay attention, focus on what I'm saying, and then go and practice afterwards. Right? So using the index form to express your square root, you then know that you could say with confidence, and the confidence is built by practice, you can say that the square root of 49 is the same thing as 49 to the power of a half, which is equal to 7. And you could say that the square root of 289 is 289 to the power of a half, which is equal to 17, etc., etc., etc. Right? So 196 to the power of a half is 14. 225 to the power of a half is 15, because 15 squared is 225. And then we could do the same thing with powers greater than 2. So we can say that we can say that 27, the cube root of 27 under the square root sign with a 3 on the outside, is the same thing as 27 to the power of 1 over 3, which we know as 3. Right? Let me see. 4 4 is a 16. 16 by 4 is 64. 64 by 4 is 256. So 4 to the power of 4 is 64. No, 4 to the power of 3 is 64. 4 to the power of 4 is 256. 16 by 16 is 256. Right. So 256, the fourth root of 256 is equal to 256 to the power of 1 over 4, which we know as 4. And then what's happening here now? I'm going to use this example because it's right here. No man, we use 3 already. So come, scrap that. 5. We can say that the fifth root of 32. See how nice numbers get to know? The fifth root of 32 is 32 to the power of 1 over 5, which is equal to 2. And why is that so? That is so because 2 to the power of 5 is 32. Right? So we would have gone through a couple examples, well, not a couple, but a few, of the relationship between the power and the root. So if the power is n, then the corresponding root is 1 over n. Whew. That's sounding nice. Let me write that now. Yeah. Right? Let me write that. Right? So for every power n, the corresponding root is written as 1 over n. Yeah. So for every power, look at nice spontaneous thing, man. For every power n, the corresponding root is 1 over n. Boom! Yes? So if your power is 2, then the second root or the square root is 1 over 2. So 2 is squared, so the square root is 1 over 2. The power that is represented by the square root is 1 over 2. If your power is 3, something cubed, 4 cubed is 64. Then the cube root of 64, the root that is represented, the corresponding root is represented by 1 over 3. which is to say then that 64 to the power of 1 over 3 is equal to 4. If the 7th root, all right, let me use a different number, make life a little more interesting, right? If the 7th root 2 to the power 7 is 1/28, then, sorry, not the 7th root. If the 7th power 2 to the power 7 is 1/28, yes, then the flip side of this, the corresponding root in here in this situation will be the 7th root, not so? If the power is 7, then the corresponding root will be the 7th root, and that will be represented by 1 over 7. So the flip side to this would be to say that 1/28 to the power of 1 over 7 is equal to 2. And that basically is it. So you get all of that, right? And again, I want to make a special appeal. Do not be under the illusion that all of these things will fall into place in one shot. If you understand everything, you still need to practice. If you don't understand everything, then you just have to practice. So whatever your level of understanding is, understanding is not the same thing as execution, right? Comprehension and execution are two different things, right? If you're learning to play a sport and you watch a video and you understand it, your coach explain it and you understand it, and then your coach will say, all right, go and do that now. A different kettle of fish, not so? Not because you know what to do means that it will just happen at the snap of a finger. So the same way that you train your body to do certain things, your mind also needs training too. Whether it's maths or any other thing that you're applying your mind to, you have to train your mind. And you train your mind by practice, by repeated practice. It wouldn't always be fun and games, but that is the system, that is how the thing is done. I am not the guy that would come and promise you to understand everything in 2 days or 2 weeks or even 2 months. That is not how this is, and that is not how most things in life are. If you want to learn how to do something, let me quote one of my favorite musicians, a fellow called Richard Bona from Cameroon. He is a bass guitarist. One of the things I've seen him say more than once in his YouTube interviews and whatnot, he says, if you want to be very good at something, you got to do it all the time. That is what he says. He says, if you want to be very good at something, you got to do it all the time. Now, all the time doesn't necessarily mean 24 hours a day. There may be a day or two where you might spend the whole day doing it, but the idea is that you had to practice and you had to be consistent. You had to do it all the time. So whether it's 1 hour a day or 2 hours a day or half an hour a day or whatever, I want to take this opportunity to encourage you all to understand and recognize the importance of discipline. Like everything in life, some days will be harder than others, but the commitment has to be there if you're really trying to understand this thing. Yes? Right. So let me round off this video by going back here, because now that we have a sense of what the 1 over n means when we're talking about powers, the next thing we could do now is integrate it into this rule that we just did here, which would have been rule number 5 on my list. We could integrate it here. Because if we're saying that a to the power of m over n is a to the power of 1 over n, now you understand why I put the 1 over n. Because if you could see the root first, you take the root out, you get the smaller number by taking the root, and then you raise the smaller number to the power. Right? Because if you have 16 to the power of 7 over 4, that is the same thing as saying 16 to the power of 1 over 4 raised to the power of 7. 16 to the power of 1 over 4 is the fourth root of 16, which is 2. Remember I mentioned in a previous video, you had to know your powers up to a certain level. Nobody expecting them to know what 7 to the power of 5 is by heart. But 2 to the power of 5, yeah? 2 to the power of 5 is 32. Right? So the fourth root of 16 is 2. 2 to the power of 4 is 16. So yes, your powers of 2. Very important. 16 to the power of a quarter is 2, which means that 2 to the power of 7 is 128. So even if you're using a calculator, it is much easier to do this than it would be to do this, which is you could do the other way too, you know, and you're getting the same answer. Watch, and we will demonstrate it. I could say that 16 to the power of 7 over 4, again invoking the commutative property of multiplication, I could say that that is the same thing as 16 to the power of 7 all to the power of a quarter. And now I mean seriously, 16 to the power of 7. You don't really want to do that, right? But let me do it now, just for the sake of argument, right? Because sometimes people will be in a class and have a whole big argument about that, not understanding that it is just 2 rows leading to the same destination. You don't have to fight about that. So 16 to the power of 7 is equal to what? 268 million 435 thousand 456 in brackets to the power of a quarter, and then you put all of that now to the power of 1 over 4, and guess what the answer is? Ta-da! Drum roll. 128. So you see the difference between putting 16 to the power of a quarter inside the bracket and then raising the fourth root to the power of 7. You see the difference between that and this situation here, where inside the bracket you raise the 16 to the power of 7 first, and then you find the fourth roots. You really don't want to do that. Because let me tell you a secret. If you find yourself in a situation where you have to type all these numbers in a calculator, then that alone is a possible source of error. You type 1 digit wrong here, problem. Alright? So all of this is just to make the point that when you understand certain things in the maths, it puts you in a position where you could make certain strategic decisions that will make your life easier. That is not the same thing as taking a shortcut. Don't get it twisted. Because we are applying solid mathematical principles. We might take the easier path. easier path is not always the same thing as a shortcut. Right? It is the easier path, that is all it is. Right? So you see the difference between these two. Same story here. 343 to the power of 2 over 3. We take the root inside the bracket. Right? We know that 2 over 3 is the same thing as 1 over 3 by 2. So we say 343 to the power of 1/3. 7 squared. Sorry, 7 cubed is 343. So what we'll end up with here will be 7 in brackets squared, right? I put in the 7 in brackets just for emphasis here. So 343 to the power of 1/3 is 7, which will then be raised to the power of 2. 49. Problem done right there. Right? What's the alternative? Let me consider the alternative now. So if we have 343 to the power of 2/3, what's the alternative? 343 to the power of 2/3. That's the same thing as 343 squared, all to the power of 1/3, right? People want to be difficult, well, let it be difficult now. Yeah? 343 squared is 117,649. 117,649, all to the power of 1/3. And you want to bet the answer is 49? Watch. Answer to the power of 1 over 3, 117 by 117,649, comma, the power of 1 over 3 is equal to, boom, 49. Just as we've had forecast, is equal to 49. So again, you saw the difference between this and what we had before. So anytime you have a situation where you have something over something, a rational number, a rational power, which can be broken down as a root represented by 1 over n multiplied by another power, then use the root first now. I'm trying to help all out here. Right? So let me deal with this guy here. So 3 over 2, 25 to the power of 3 over 2 is what? In this case, we took the root on the inside and we said that 25 to the power of 3 over 2, we said that 3 over 2 is the same thing as a half by 3. So it means that we have 25 to the power of a half inside the bracket, all raised to the power of 3. 25 to the power of half is what? 5. You get 5 cubed, and 5 cubed is equal to 125. Well, let me consider the alternative now, because sometimes people like to be contrary. Sometimes people like to play devil's advocate. Wherever possible, we indulge those folks, especially in cases where we know the answer will be the same, just to drive the point home. Alright? So, we're saying that 25, yeah boy, we're saying that 25 to the power of 3 over 2 is the same thing as 25 to the power of 3, all to the power of a half. Right? 1 over 2 is equal to what? 25 to the power of 3 is what? 25 squared is 625. 625 by 25 is how much? 625 by 25 is equal to 15625. Let me just double check that. 15625. So what you'll end up with will be 15625 in brackets to the power of a half. Basically what you're looking at here is the square root of 15625. And that, ladies and gentlemen, is equal to 1/2. 125. Same 125. Right? So whether you take the long way home or the short way home, you still reach home. Whether you take the easy route or the hard route, you still reach. Whether you take the road with traffic or the road without traffic, you still reach. Right? So that is where we end up with that. So I want to put one more thing on the board and then close off this particular section. Listen, man, it's serious, you know? It's serious. It's real serious, this whole matter of indices. And I trust that if you're here in the video, that you would have been here as a result of having looked at the whole video from start to this point. And even beyond that, I trust that you would have been following the previous videos also in their entireties. This thing serious, it has no shortcuts. It has no shortcuts at all. Right? So one more thing before we close. Yes, I know the video is probably a little longer than you would have liked it to be, but that, my friends, is why we have the pause button. And I encourage people all the time. Pause if you must, but don't stop. Don't walk out on my video. It have too much good information there. And if you miss it, well, then that is your fault, you know. Yeah, if you miss it, that is your fault. Don't say I didn't tell you. So wet cloth first. Alright. Yeah, boy, we're not easy out here, you know. We're not easy at all. Alright. Wet cloths. And then dry cloths. Right, so maybe we could talk a little bit while this thing drying. What let's see. I think I get an even drier cloth for this boy. Papa, you hold on. Let me check my files and see what we have here, boy. Good old fashioned. Right? Yeah, boy. You're taking a little too long to dry. So here what we go. You have dry and you have dryer. Yeah. Good old fashioned clothes get the job done, you know. All them set of fancy duster and thing. Right, so watch carefully now what we're going to see here. And this is just a variation of the last set of laws that we were dealing with. We said that a to the power of 1 over n as the nth root of a is written as a under the square root sign with an n up in the corner. We said that. We said that a to the m over n is a to the 1 over n in brackets to the power of m. Well, no. Right. Sorry. And we also said that that was equal to a to the power of m. Well, we didn't say that, but we did the examples in brackets to the power of 1 over n. So we more or less said that, right? Remember, yes, we did say that earlier on in the same video. We invoked the commutative property. 1 over n by m is the same thing as m by 1 over n. What's the reason why I'm doing this? Watch carefully. If we're saying that a to the m over n is equal to, that's an a and that's a 9, is equal to a to the m to the power of 1 over n, then that can be written as, and this is the form that a lot of people are familiar with, a to the m, and then you put the square root sign with the n on the outside. So in other words, what you have is the nth root of a to the power of m. That's basically what it is. A to the power of m, and then you find the nth root of that. So this is the form that a lot of textbooks will give it as. Of course, they probably wouldn't spend as much time explaining it and illustrating it as we did here in this video. So, coming on the heels of everything we just discussed, then you could understand now why a to the m over n is a to the m, the nth root of a to the m. So in other words, a to the m under the square root sign, and you have the n on the outside. Because once you understand that a to the m over n is a to the power of m by the nth root, in other words, sorry, a to the power of m all raised to the power of 1 over n, which is the same thing as taking the nth root of a to the power of m. It means that you can then take a to the power of m under the square root sign and put the n inside it. So in other words, we can say, and this is another form, we can say then that a to the power of m over n is equal to the nth roots of a to the power of m. So that is an alternate expression of rule number 5, which I will have to put it as when I'm typing it up. But the key to understanding that is to understand what we took the time to explain in rule number 6, which is that a to the power of 1 over n is equal to the nth root of a. Once you understand this form, then you could go from here to here, and then you could just go to here. Right? So you know that, and you also would have known it where we took the root first. So anytime when you take the root first, the expression will be a to the power of m over n is equal to a to the 1 over n to the power of m. If you want to use the square root sign, which, alright, let me just be difficult now, because I know some people like to be difficult. Alright, so here what we're going to do, I'm going to delete everything that I have here. Hear me now talking about delete. I with a big whiteboard with 2 cloths in my hand and talking about delete. You see how the computer language just creep into your regular usage? If you're on a whiteboard, you're rubbing off, you're not deleting. Deleting is when you're on the computer, or when you're on the phone, or when you're on your social media. You understand? Yes? So we can say then, using this form, we can also say that a to the m over n is equal to the nth root of a of prime. A to the 1 over n. So the nth root of a all in brackets to the power of m. I have seen this in textbooks before, but if you notice, and I want you to pay very close attention to the fact that in terms of my own explanation, I spent the majority of the time using the fractional index form. And once you understand that, it is then easier now to write it over using the square root sign. So that if you happen to be in a jurisdiction where they're using the square root sign exclusively, then the intention is that after you go through my videos, you wouldn't have the problem of not understanding what it means. Because if you could understand that when you have a power inside the bracket and you have power outside the bracket, it multiplies, then you could take that, you could work it in reverse and break it up into the product of a root by the power or the product of a power by the root. So here what I'm going to do. I'm going to go over everything that I just said by just writing it on the board so that you could see one more time before we close this video the connection between the powers and the roots, between the fractional form of the index and the square root form of the index. So here what we're going to do. Let me rub off everything that we have here. Right? Well, I find this video long, boy. I find it long too, you know. I find it long too. But if it's long, it's long. We can't spend all the time whining about that, right? We just have to get on with it. Just have to get on with it, man. Yeah. So here we're going to do. If we're saying that, watch it now. Introducing the fractional index, and this is what I want to understand, because you will almost certainly meet up with this fractional index form. Right? If you have, let me use the general form. A to the power of m over n is equal either to a to the power of 1 over n, you take the root first, raised to the power of m, or it is equal to a, you take the power first, the power of m, and then you find the nth root of that. We went through that, we used examples, and you saw that regardless of which path we took, we ended up at the same destination. Now, from here, you could say that this is equal to A. It couldn't look real nice when we finish. Let me space it out a little bit because we need more space here. You see? So let's pay attention. Pay attention. Alright? Watch carefully what we're going to do here now. And I will use different colors of ink just to drive the point home. So we started in blue and we're saying that in black we have, let me start with black. And we go to blue and red, right? Yeah. So in black we are saying that A to the power of m over n. And then in blue, we say that that is equal to A to the power of 1 over n all to the power of m. And then in red, we're saying that that is also equal to, now, let me come down a little bit. That is also equal to A to the power of m to the power of 1 over n. Now, in blue, we're going to switch from the fractional form of the index to the form where we're using the square root sign and say that this is the same thing as the nth root of A in brackets all to the power of m. And then we could say here that that is also equal to saying the power of a, you take the power of a, and then you find the nth root of that. It's the same thing. This is the same thing as this. Yeah? Right? So therefore, at the end of the day, your second line will read that a to the power of m over n, you have it in the fractional index form, or you have it in the square root form. So in terms of how it will go through my head, I'm not saying that to say that that is how you have to do it. If you understand it like this first, then power to you. Everybody understands the thing differently. But I think it's simpler like this. But if you think that this is simpler, that is not a problem. Right? I'm just teaching it one way, but I'm also leaving room for the other way, or ways as well. So what I tend to do is, if we are not sure, remember the multiplication. M over n is either 1 over n by m or m by 1 over n. Once you remember that, that will then give rise to your a to the power of 1 over n is the nth root of a. And that is multiplied by the m. You still have the m on the outside. Or you could say that having raised the power of a to, having raised a to the mth power, m is the power of a to the power of m, you then find the nth root of whatever that is. So you raise a to the power of m, and then you find the nth root. It all goes back to the same a to the m over n. So that is it. We will stop right there on this video. So in this video, we will have covered rules 4, 5, and 6. Right? And you see how they all intertwine with each other. As I told you before, some rules are just different expressions of the other rule. Right? Right. So we will stop there for now, and we will continue with the other videos where we go through the rest of the rules in this thing. Yeah, we have a little distance to go still.